friends, welcome to programming languages for civil engineering students. In this video I will explain how to construction of response spectrum graphs. These response spectrum graphs are very useful in structural dynamics. To perform the response spectrum analysis, these response spectrum graphs are said to be very important. Okay, and these response spectrum graphs also very useful to design the response spectrum graphs, design response spectrum graphs. Okay, in this present video I will only discuss how construction of response spectrum graph by using Matlab. Okay, and I will tell the procedure. Okay, first we have to select the ground motion with a time step. Let us say 0.02. Generally the time step is 0.02. Then select a frequency and damping ratio. Let us say select any particular frequency at any instance, first instance, and damping ratio. You can select any damping ratio, 0.02 or 0.05, something like that. Then compute the deformation response of SDOF by using any numerical methods which mentioned in any standard structural dynamics books. Okay, then we have to solve the dynamic equation, dynamic equation of motion by using any standard numerical methods. Let us say some of numerical methods are Newmark's method, central difference method, Wilson theta method, and interpolation method, or piecewise method, or Wilson recurrence method. Okay, after finding the response, then we have to find the absolute maximum displacement response of the single degree of freedom. Okay, then after finding, then we have to find the response spectrum velocity. For the response spectrum velocity, the formula is 2 pi by Tn into Sd, that is response spectral displacement. Similarly, response spectrum acceleration is equal to 2 pi by Tn whole square into Sd. Okay, you will get response spectrum acceleration. So repeat 2 to 4 steps. Again we have to repeat from 2 to 4 for different frequency or time period, and also for damping ratios. So after repeating, then you will get the maximum responses in terms of displacement, velocity, and acceleration. If you plot the responses as time period in x-axis and the SD, SP, SA in y-axis, finally we will get the response spectrum graphs. Okay, we can write this code in either Matlab or Scilab or FreeMat or GNOC 2. But if the ground motions are very large, that is the time of the ground motion is very large, then this Matlab and Scilab or any these programming languages are not that much very useful, because they are very slow. So if you want to perform quickly better, prefer Fortran programming language. This Fortran programming language is very useful. Within seconds we'll get our HD, SA and SV values. But in this Fortran programming language we don't have any directly graphical user interface, graphical graphs. We cannot get to the graphs. But by using GNU plot, just a software, just by calling GNU plot after writing some very simple code, then you can plot whenever you run the Fortran program, automatically you will get your response spectrum graphs. Okay, if those who are not able to draw the graphs in the Fortran directly, then you just see my previous videos, will get a glimpse on that. Okay, I already developed a code in this Matlab. Okay, just I will run. This is the code. Okay, just I will run. Then you have to browse. Just I'm browsing the Chamba ground motion. Just you have to give the model damping ratio. Let us say 0.05. Then after we will get response spectrum graphs in terms of acceleration. This is acceleration, you can see here. Okay, this is acceleration, this is velocity. Okay, this is velocity, and this is displacement. Okay, this is displacement. So in this way we can easily perform this response spectrum, construct a response spectrum graphs by using Matlab. Anyway, thank you for watching this video.